expected value. We have to use the probability. Remember, so I said the probability. The first topic always is the most important topic is for unit 2. So today we use probability to find something or expected value. That's the major. Okay. Expected value to 2.2, right? Okay, expected value is done. What does expected value mean? It means how good we is a kind of a tool for us to measure how good is a game for you. So suppose we go to gambling, it's not good. Okay, suppose if I go gambling, I have a probability to win the game. I also have another probability or the opposite to lose the game. If I win, I get money. If I lose money. And if you play a lot of time, do you think you have a way to tell is the game good for you or not good for you? We use this expected value just to tell. We don't need to say gambling probably like an investment. Okay, if I invest my money to the market, that's good, right? And the same, similar as like a game. I probably win. I also probably lose. No one knows. It has kind of a chance to win, kind of a chance to lose. And the same with the I use this expected value to tell is this a good investment or a bad investment? Okay, let me give you an example first. Try to get the method, well, try to get the idea. Okay, the concept. Let me give you this example. If I play a game, let me say I play a game, whatever investment, have a probability to win, right? I also have probability to lose. This game, let me say, like I have a 40% only chance to win. Win how much dollars? Suppose I say $10. Okay, I have a 40% chance to win. If I win, I get $10. Okay. And another, of course, I have 40% to win, 60% to lose, right? So 60% of the chance to lose the game. If I lose the game, I will lose money. Let me say how much money. What chance should have a lose less? Probably like $5. Is that okay? See, the game I have 40% to win $10, 60% the chance to lose $5. Now, how about the game? Is the game good for you? Or is this a good investment for you? The question, is this a good game? For you? So everyone, can you think about this question? Or any idea? Well, whatever I play a game or do investment, I always have this kind of question. Okay. So finally, we come out a method we call expected value. But I think you also can find it by yourself. Can you? Anyone think? Oh, Fiona?
I don't think it's a good game.
You don't think? Why you don't think?
There's a large percent chance that you're going to lose money. So, and a small percent chance that you're going to win anything.
You have more chance to lose money. Yes, I know,
So that's why like.
but I lose less money than I get, right? So think about the case. This is a reason, but this is not strong, right? It's not so strong to support why this is not a good game. But I can tell this is not a good game. This is a good game. It is a good game. How do you say why this is a good game? I have a small chance to win big money, right? I have a big chance to lose 5. The way to think about it, I said this should be a good game. I mean, if I play the game with you, I follow this rule, it's good for me. Okay, it is good. Why good? I can do this. See, I have 40% of the chance to win, 160% of the chance to lose. Can I play like 100 times or 10 times or 5 times? Okay, whatever. You just think about it. Because the game is just fair. Okay, each time is the same randomly. If one time of the game cannot tell, sometimes I win, sometimes I lose. Can I play more times? For example, I play 100 times. If I play 100 times, what does that mean? Randomly speaking, okay, or general speaking, 100 times or so, I win how many times? 40 times. Does that make sense? Because I have a 40% of the chance. That means I play 100 times, I will win 40 times. Then I lose 60 times. And then I can do the calculation for the total money. I can calculate it because if I win dollars. If I lose dollars. So that I can come out of all the money. If finally I win money among the 100 times, okay, I know this is a good game for us, for me, right? Otherwise, it's bad. Even that is not a difficult to do calculation. Everyone now, can you think? Let's imagine. You play 100 times, okay? Play 100, or you play 5 times. If you play 10 or 10 times, if you play 10 times, you will win 4 times. You will lose 6 times. If you play 5 times, you will win 2 times, and then lose 3 times. Is that okay? So the same, right? The same like I make the game more, will be more accurate. Play 100 times. We should win 40 times. And then lose. I get this smaller, sorry. I mean, be patient. Too big, I need some space. Okay, look at this. Now, if I win 40 times and then I will lose 60 times. Okay, how much money I gain or how much money I lose? I just look at the money and check the result. Okay, the total money. So let's do calculation. I don't know the money is gain or lose. Okay, I have to do calculation. I win 40 times. Each time I win $10. See, so 40 times 10, 400, right? See, I get a 400. However, I will lose. I lose. I use a minus. Is that okay? Is a minus to tell lose, man? Lose how much? 60 times times $5. Okay, each time I give the opponent $5, I give 60 times, so 60 5 all. Get this. Therefore, I do calculation. Can you see what is that? 400 minus 300. I get $100. Do you know what that is? $100 mean? Means I get $100, right? Among the 100 times of the game. It's not a lose, right? So now, can you tell? Is this a good game for me? For you? It is. See, it is. But I say this is 500 is 100 times, and then we don't need to really do 100 times. We can do 1 times this time. Okay, get the average. Can we? If I play 100 times, I win. See, $100. Play 100 times, I win total $100. In average speaking, how much money you win for each game? How many? How much? 100 times you win $100. So each time you win $1. Okay, so that one is expected value. Okay, so now, and this means we can get this. Let me use another color. So you get the same question now. Yeah, average speaking. Or you just look at the average, okay? Look at the average each time or each game. Times. So therefore I win $1. Okay, so you get something. This is $1 we call equals expected value. If the expected value is a win, okay, it means a good game for me. If it's not a win, lose means the negative value. Imagine if you do the calculation, you get the money is negative, means I lose money, right? Okay, in total times lose money, you average each time you still lose money. You have expected value, negative number means you lose money. That means it is not a good game for us, or it's not a good investment. Make sense? Okay, so look at not difficult, right? Really, okay. It is, but we also come out, we summarize to get a formula. So that the next time I don't need to do this way. But whatever, if someone like this is the original way, okay? The original way is like this. You can set up like a play 100 times or play 10 times or play 5 times, whatever. If you set up the times and then you know how many times you win, how many times you lose, and then you can calculate the total money to get the average, okay, which is the expected value. But now I show you a formula for you. I will try to get another formula. Now, formula. What do we get? Just yeah, I use this color again. Anyone remember? How did we get? We get a 4. See, I just use all the expected value. I just get a. Let me think. EV expected value, is that okay? Expected value, or use E to describe or whatever. And we just did this calculation. The total outcome. Okay. Or whatever is the total win or the total lose. Okay, so that just is the total outcome, and then over the times, right? Over 100 the times. let me put this. The total outcome, just we have what? We have, I forget, it's $10. If I win, I get $10, right? Anyone remember? Get $10. Okay. So we just use 10, remember? Get $10. These 100 times we just did. These 100 games, okay, or 100 times of the games. And this is the total outcome among 100 games. And then I will get $10 for each game. I will win 40 times of the game. And then I will lose, right? $5 each game. I will lose total 60 times of the game. And then over 100. And so we just did this calculation. Is that okay, everyone? Okay. I win $10 for each time. I win 40 times. I lose $5 for 60 times. And therefore, this is the total outcome among 100 games. And then over 100 games. So I get the average. Okay. Expected value means the average. See, each time I will win $1 is the average. And then I separate these 10, everyone. So I do this, the 10 times 40 over 100. This minus, let me write a plus. -5 times 60 over 100. Is this the same? Everyone, is this the same? This number divided by this number, which is 40 divided by 100, right? And this number divided by this number, which means 60 divided by 100. Plus -5 times means -5. Okay, it's the same. So now definitely we can get something. Do you know what this? Can you see? This is a formula. Okay, I win. This is the outcome, right? For win. This is the outcome for win. Win, $10. Now what is this? Is this 40%? This is the probability for win, right? So I win $10. I win with the probability 40%. This is the probability of the first outcome win. And then the same pattern. Okay, you can see the pattern. -5 is the outcome for lose. But if I lose, then I lose $5, which is -5. This is the outcome for the second case, lose. How about this number? Is this for a 60%? Yeah, definitely. This is the probability, right? So this is the probability for lose. I think you get. Or whatever. And finally, I have a formula. Okay, the formula give us is expected value or the average is the outcome times probability. Plus another outcome times another probability. I hope everyone you get this. And then I summarize the formula. Make sense? Any question? I get a formula now. The formula says average speaking each game, okay, how much money I will win or how much money I will lose can be calculated by this product, okay, or product of what? Of the outcome and the probability. Outcome and the probability, okay? If I have 3 cases, okay, whatever is the sum of product. So finally we get a conclusion. Average value, okay, or expected value is the sum of product. So that's all. Okay, so that's all the formula we have today. So get a formula for expected value. You know what is the expected value, right? Okay, is this? Let me get it. We need to look at the outcome, right? We need to look at the probability. And this is a game. Outcome, if I, for example, if I win, okay, I win whatever, how many dollars? How many dollars? I will use number. Is that okay, everyone? Or let me put this number. This is money now. Can I just put $8? Is that okay? Okay. If I win the game, I win $8. In our example, is win $10, right? And I say the probability for this is P. I use A1, the money. Whatever, I use A1 to describe. So this probability is P1. Is that okay? And then if I lose, the second case, if I lose, I will lose dollars. So like A2. In our case, it's -5. Okay, so -5 is A2 in our example. Right? And A1 is $10 because of A1 in our example. But I get the general formula, which is this is the lose, and then the probability is P2. Okay, so can you see? And therefore, the formula we put down equals expected value. We just get the outcome, which is A1 times P1 plus the second I lose is A2 times P2. Is this the same as we just get? Or we can write it in this way. This is the outcome. We say this is the outcome 1. You probably don't like that. So I write another way. It's easy. This is the outcome 1. The first outcome, let me say, is the first outcome, and then times the first probability. Okay. And then plus the second outcome 2 times the second probability, probability 1, then the probability 2. If we have a 2 case, it's just like this. And usually mathematically we call this is the sum of product. And then what the sum? Yeah, this is the sum. Where the product is here. If I put here, the product is just this number times this number. See, this is the product, and this is another product. The sum of product is this product and this product. Okay, so that's the formula. Any question? And then I will ask you 2 questions. I only give you 2 outcomes. This could be extended to more than 2 outcomes. Okay. It is also possible. And then later I have example, I have more than 2, like 3 outcomes, but the way is the other same. Outcome times probability, outcome times probability, add together. And then let me ask you a question. Okay, so here the first. Whatever the way you like, you can use the formula that I just summarized, or you can use the original way we solved, okay, for the first example. So which way is easy to which way? You see, here we have a game. A bag contains 10 gold marble and another silver marble. Someone offers to play the game. You randomly pick a one from the bag. If you pick a gold, you win $5. Otherwise, if you pick a silver, then you lose $1. What's your expected value? So now you know what the expected value mean, right? Suppose you play a lot of times, and each time you win or lose, you probably get a positive number. Probably, yeah, Destiny. What? Oh, let me see. Yeah, I recorded. Yeah, good. Thank you for reminding. Almost. Thank you. I recorded the session. If someone loses something, okay, you can check the recording. You know, the recording is always in the Blackboard, right? Okay, so you can find. I don't want anyone to miss something. The topic is not difficult, okay? However, the beginning, you know, the concept is important. Okay, so how do you solve this problem? We just already solved one. And also we come out, we summarize to a formula. I will use the formula. Is that okay, everyone? I will use the formula. I just get use the probability, use the outcome times the probability, and then outcome times probability added together. Okay, so to get the average. You see, this definitely is a game, right? I have a probability to lose. I have a probability to win. So therefore, two outcomes: either lose the game, win the game. So that I can build a table similar as this small table. Okay, so most of the question, everyone, most of the question, we have two outcomes: either we win or lose. So that all the question has the similar like this table. I always build this table. Okay, from this table to get the answer is easy because this number times this number, and then add this number times this number is the average. Now let me build the table. Yeah. So this is the game, and then I need to find expected value, which is I have to find how many outcomes. What's the corresponding probabilities? Two cases. The first, I win the game. I'm to say the first row, I put the information for the case that I win the game. Is that okay? The first is for win. The second is for I lose the game. If I win the game, I get how much dollars? Oh yeah, $5. So that I put a 5 here. That's good, right? If I lose $1. Keep in mind, remember in the example, if I lose $5, I use -5. Do you remember that? I have to use -5. Otherwise, if you win, you get money. If you lose $1. You still use one, you also get money. Positive means get money. Negative means lose money. If you lose, put the negative. -1. Which means -1. This number is -1. This is a 5. And then one more step is to find the probability. Okay. Anyone give me now? Andy, try to give us. What's my chance? What's your chance if you play a game? What's your chance to win the $5? How many? 10%. Okay. How did you? Yes, you're right. How did you get the 10%? Yeah, very good. See, you get a $5, it means you get a gold, right? So that's the probability. Okay, we learned that from the beginning of this unit. What's my probability to get a gold from the back of 10 gold out of total? Total is 100. So 10 out of 100, which is 10%. Make sense? Okay, good. We got it. This is 10%. Yes. 10. Which is 10 out of 100. 10%. Okay, so how did I get this 10%? It's 10, the probability here. The probability to get, this is the probability to get a gold, right? Random pick, get a gold one, a gold marble from the back, which is the gold is 10 gold out of 100, so therefore it's 10%. Okay, and then you get it by this way, right? Classic model. Can you answer the second? So how many chance? What's my chance to lose the game? 90%. Yes, good. 90%. So everyone, have you seen something? Is the 10% plus the 90% always 100%? That's true. Okay. Remember, this is the complementary probability we learned. Okay. This probability is PA, and this is a PA bar, right? They added together is 100%. If I have a 10% to win, then I have a 90% to lose. Okay, so I hope you can get this small. Let me use another color. Probably this. Have you get it? So this is the sum always, okay, definitely. This is the sum equals 100%, which is 1 always. If you work out problem and then you find that these added together is not a 1, means that you did something wrong. Okay, means that you did something wrong. And then, Andy, can you finish this work? What is the expected? How did you calculation now?
The equation.
Yes, the setting up.
5.
Yeah, good. It's a 5. Yes, and then times 10%, right?
Yeah.
Or if you somehow you don't like a 10%, you can put a 0.1, and then this is a 0.9. Is the same, okay? And then
it's -1.
yeah, plus -1 times 90%. I think you find that see as this the similar okay way as we solved the first example. I win $5 as 10% of the chance. I lose $1 with 90% of the chance. The sum of a product. Okay, everyone, this is the way we can solve. You just do this. You just put this times together, and then put this times together. This is the product. This is the product, and then add the two products together. The sum of the product is the expected value. Anyone give me your answer? Here should be 0.5. That should be -0.9. So it should be -0.4, right? Okay. Can you get? It should be -0.4. What does this number mean? Expected value is here. What does this number mean? Means what? Anyone tell me? Is this means that this is a good game for you, or not a good? Not a good. But because I see a negative. So what does negative mean? Lose money. Yeah, lose 40 cents. Is among a lot of times or a single time? Single time. Remember, this means the average. Okay, so I put it here. If you get this expected value, means in average speaking, if you play a lot of times, and then each time you will lose 40 cents. Okay, this means this. means you will lose 40 cents each game if you play a lot of times. A lot of times of the game. You will lose this each game in average, okay? In average. Remember that's the average. I think this is the one expected value, okay? In average speaking, you lose 40 cents each game if you play a lot of. Okay? But does it mean that if you play one game, you definitely will lose 40 cents? Of course not, okay? You play one time, probably you get money. It is possible, right? Because you have a chance. Okay, so that's the first example. Look at this topic is easy, right? Is this easy? Yeah, it's not so. This is the easiest question. I will give you a few more other questions. Gradually, you will see this topic is not easy. Okay. Why? Have you seen something? You have to find a probability. What if I don't know what's the probability? Definitely, I cannot get what's the expected value. So keep in mind, you still need the probability as the foundation. Let's do a few more questions. Have you gotten the idea? Chris, do you have a question? You get it? Everyone, you have got the big idea already? If you are here, can you type yes to let me know? Yeah, thank you. I want everyone to be here, so don't go away. I said this topic looks easy, okay, but it really not, because you need to find a probability first. I have another few questions. I want you to practice. Second. I always do the same way, okay? I use the formula. Is that okay? I use the formula. I put the table and then find the sum of the product. Can you see? No? I'll click it again. Diana, can you try to help us to figure out this question? So first, the table is the most important. Almost all the information is in the table, right? So I really hope that when you do your work, build a small table so that you will not make a mistake. So that's get the table. The table including the first column is outcome, the second is the corresponding probability. This is a game. So that we have two cases. I either win the game or I lose the game. Yeah, Diana? If I win the game, how much money I will win? $2. $2, good. No, not the $2. Not $2.
Well, it's because you have to pay it in order to.
Yeah, so everyone be careful, okay? This is the $1. If I win the game, I do not really win $2 because I spend the $1 to play the game. Make sense? Everyone's very small detail. Because you have to think about it, you cost the $1 and then you win, you get a $2. So therefore, 2 minus 1, you get a $1. You get a $1 into your pocket, okay? So you get only $1. So this one I get, is a $2 minus 1 equals 1. Okay, so just think about it. And if I lose how much? Yeah, good. See, just the cost is $1. So therefore, I have to put the -1, right? -1. -$1. Okay, I just put this side here, which is -$1. I will lose. $1. And then the most important is this part and this part. And you do what's the probability I will win $1, Fiona? 33%. Oh, yeah, good. Can you give us a fraction? It's better to understand. 26. 26. Good, let me get it. 26. Why is 26?
Because you 6 cycle of time.
Yeah, see, what to win, how to win. You just get a 5 for all 6. So you have 2 outcomes to be successful. And then out of 6, you roll a die, you probably get a 1, 2, 3, 4, 5, 6. So 2 out of 6 is the probability. Okay, good, thank you. So therefore, what's the probability here? Yeah, 4 over 6. But this number, we don't need to do anything. Remember, the sum always 1, right? The sum always 1, so therefore this is 1 minus this fraction, which is 4, 6. That's good. Or you say, this is a 1 minus a 2, 6, 2 out of 6. So that I get a 4 out of 6. Yeah. If we go here, then easy. You just Fiona, is this the way we do? The product is these 2 numbers, and another product is these 2. These 2 numbers. See? And then they come together, just do simple calculation. So the expected value should be equals $1 times 2 out of 6. Then that's negative. Don't miss the negative. Okay, so -1 times 4 out of 6. So we do calculation. Is 2, 6 minus 4, 6. So it should be -2 out of 6. Which is a -1 out of 3. It's better. I get it. Yeah, really. It's -0.34 cents. No, dollars. Dollars. This dollars means 34 cents. That's a negative 34 cents. So you get a 34 cents. That's the way, right? Good. Thank you. This is the answer. What does this answer mean? Anyone can? Oh, Fiona, can you get? Yes, you average if you play a lot of times, so that each time you will lose 34 cents. It's not a good game. Okay, don't play, right? If all is randomly, don't play. This is not good for you. Or don't invest your money to this game. Can you do one more now? Actually, we have. Is that okay, everyone? I have another 3 questions. Okay, it's all the same, but gradually you will feel it's more complicated for the probability. Sometimes it's complicated for the probability. Sometimes it's complicated for the outcomes. See, here is very easy. I just put the 2 at the beginning. No, it's not a 2. It's just $1. The third, right? Okay, so it's this question. I hope everyone you get the big idea. Okay, so that's the topic, and then you practice. You also have some questions in the homework. You are given 5-to-1 odds against odds, prevalent odds. Okay, means what? Means you win 5, you lose 1, right? Okay. You win 5, you win 5. If this dollars means when you win $5, and when you lose $1. So 5-to-1 odds. Okay, but depends on what's the rule of the game. So look at the game. Posing a fair coin means you just flip a coin. Flip a coin. Flip a coin. Get 2 tails in 2 tosses of a fair coin. If I have a coin and then flip 1, get a tail, and then I flip the second time, get a tail. It's not easy to get, okay? Imagine if I just flip once, what's my probability to get a tail in the single game? 50%. So what's my chance to get a tail again in the second step? 50%. If I see this is the big event, what's my chance to get a tail the first step and then get a tail in the second step? Multiplication, right? Remember? So what's my chance? 0.5 times 0.5, so 0.25. So you only have a 25% of the chance, okay, to win. Does that make sense? Multiplication, okay, so you still need the multiplication. The probability. What is the question? So let's do similar. Outcomes, the probabilities, either win or lose, right? So this game is just either win or lose. I only have two cases. So let's say this is a win, this is a lose. Jonathan, can you try to figure out this number, this number, this number, this number, please? What's the money I have to put here?
$5.
$5 to win. Do you need the cost to play the game? They did not say. So I don't know. Okay, so they did not say. So I suppose I don't need the cost. Okay, so it costs nothing to play the game. So if I win $5 here,
It'd be $1.
$1. Can we put a 1 or -1? -1. I lose, use -1. Is that okay? Everyone lose is negative. So it's $-, $1. What's the probability here? 1 by 1. What's my chance to win? How big is the chance to win the game? Win the game if you succeed. You succeed on here. We just think about posing to get a tail, and the tail means get a tail. The first step, get a tail in the first, and then get a tail again. And second, so T, remember that? 2 steps. So therefore, the probability should be 25%. We just did 25%. Or you say it's 1/4. Is that okay? I use a fraction. So here is a 1/4. Why is 1/4? We just get the reason. The probability get a tail, the first, and then get a tail, the second, and the right is the tail and the tail. So therefore, is the tail on the first tail. Let me see. This is the first tail. The second also get a tail. So therefore, is the probability. The first step I get a tail, and then time is up. This is independent, right? This is independent. You flip a coin. The first step definitely never affected the second step. Independent. So therefore, the time is the probability. The second step, you still get a tail. See the multiplication, and then here is 1/2. The first times 1/2 the second. So that's 1/4. That's why we get a 1/4. If someone you did not forget what the multiplication, you have to check the first topic that we learned in the 2. And then anyone give me what's the probability here? Now, Jason, what's here? Yeah, what's the probability to lose? 3/4. How did you get 3/4?
times, so we can never do 3/3.
Okay, so you want to say, if you have 4, see, you win 1 and then you lose 3, right? Of course, that's 3/4. You are right. Or another way is just how to get this. If someone you can do is just do this. 1 minus this, right? You have 1/4 to win, and then you have 1 minus 1/4. Okay, the opposite or the complementary to lose. That's 3/4. Okay, after this, and then this product, we get the answer. Is that okay? Say similar. And then I think I want to know for this step. Equals back to the value now equals $5 times 1/4 plus -$1 times 3/4. Do calculation. So the 5 minus 3 is 2. 2 over 4. 4 is 0.5. $0.5, okay, which is 50 cents. And that's the answer. What does that mean? Oh, 50 cents is good. Okay. So this game is good. Or this investment is good. Because in average speaking, if I play a lot of times, each time I will win $50.50. So of course that's good. And then let's do another. Is that okay? Let's see. I'll see you another question. Practice a few more. And this time, definitely the probability is easy, but the outcome is not easy. Outcome is not easy. When you figure out, I want someone to help. Fanny, right? So can you help for this question? Yeah, try. The first step, we finish the table. This is the outcome. This is the corresponding probability. What is this question? This question is not talking about the like a game, but you can see the question is like a game. You're going to buy insurance, okay? It's a home insurance, house. The insurance of the house. See, to insure this big money for the total value for $560 is the annual premium, which is the insurance pay. Okay, if you buy the home insurance, so every year I have to pay like $560. If the company spend $30 per year to do service such a policy, means the company has to take $30 to do some service, and then the probability of the total loss. We see something. Home insurance, probably the home like an earthquake or something. Okay, if there are big damage to the home, to the house, and then the insurance company need to spend a lot of money. Okay, to fix the damage. How big the money the insurance company need to give? This is the big money, okay, the insurance company. But we also have a small money the insurance company need to spend for services, and the $30 each year. So how about you? You pay these dollars. This is the game, right? If I talk about the company always get $560 from each customer, and then the probability of loss a home. Yeah, one probability. You just think about what the number you have. This is a probability, and you assume either total loss or no loss. Can you see two cases is total loss or no loss? Let me put it here. Okay. Here, if here is total loss. The first case is total loss. Is that okay? The second case is no loss. I put the words on the side, just a reminder. Okay, myself. what is this row mean? Okay, just put a notation like that. What number here? Or Penny, can you try to think about the probability? I said that the probability is easy for this question, but the outcome is not easy. Can you do this one first?
The probability for total loss is 0.001.
Okay, so put it here, right? Good, good. Thank you. So put the probability here as 0.001. Because it says this is the probability for total loss. See total loss here. Then what is this? Should be here.
Nine.
99.99, no, not 99.
Nine.
0.999.
Nine.
Okay. If you change it to the percentage, is 99.9. Okay. How did you get this?
You subtract the-
Subtract this to 1, right? Okay, 1 minus. Everyone, so you get this important. Okay, so we always use, but the sum is 1. So you know 1, then you know another. Then the challenge. Total loss. No, okay, I want you to do this first. Second. No loss. No loss means nothing damage, no damage to the home, right? In that case, have to think about it. See the question. Let me highlight a little bit. The question asks expected value for the company. Okay, this is for the company. It's not for you. Suppose you are the boss of the company, and then you calculate if you this game is good for you or not. Keep in mind, okay, this is for the company. So therefore, now you have to think about it. You are the boss of the company. So if you no loss to your home, how much outcome, how much money you will get? Are you sure? Let me put it first. 530. Yeah, good. How did you get a 530?
Because you have to pay 560 per year.
Yeah, very good. Okay, so you already got it. See, if no damage, I always get it. If you are the boss, you will get this insurance pay plus. Get the insurance, but spend the $30 to do services. Okay, which is a 560 minus 30, that's 530, right? Yes, very good. 530 make sense? Everyone, does it make sense? 530. Yeah. Then we get a 530. Put the sum better. Let me put here. That is the no loss. You are the boss, you get this number and then minus 30. So you get a 530. This is the way we get it. And then the second total loss. That's a 2 calculation. And how do you 260,000 is 260,000 there? Positive or negative? Why is it negative? Yeah, because you lose. Keep in mind that you lose for the negative. See, for example, this 560. Why is it 560 means positive, right? Get money and lose money. And this is a lose. The boss of the company spend the big money to fix the damage. And then what? Are you sure it's only this? This is another case. These 2 cases are separated. Okay. In another case means that we will have a total loss to the damage. But whatever the boss or the company will receive the insurance pay, can you, of course, If I'm at the boss, I will get the insurance pay from the customer, right? Is that okay? I always get this money. How about the $30? Subtract of that 30. See, this is not easy. In this case, total loss case, okay, I think about it, the outcome of the company. Get $560 from the customer, okay, insurance pay. Spend the $30 for the service, the sales always. But the boss has to spend the bigger money to, okay, the damage, okay, which is negative. This is positive, this is negative, this is negative. Can we do calculation? Anyone, you do calculation for me? Can you do calculation? I get a number. It's negative, these big number. And then positive 560. And then minus 30. What's the number you get? Should be negative number. Anyone get? Anyone get?
259,000.
Yeah, good. 259,000.
470.
470, very good. So we can calculate it easily. Let's get this number. So let's put this number here. Okay. Can you think about it? See, this is complicated, right? Okay, it's very easy to make a mistake. Very, very easy. So I get a negative $259,470. This is a negative. And then the last step is easy. Just a leave for you. Okay. You know the outcome and time probability. You know the outcome and time probability. Okay. So therefore, so expected value should be this number, big number, times 0.001, and then plus 530 times 0.999. I don't know. So let me get the answer. Or you can do times 0.001 plus 330 times 0.999. How many? So my calculator at 270. Did you get it the same? So 270 is, if I did not get it wrong, so 270 is the expected value for the company or for the boss. This is the answer. What does 270 mean? Means each game, the boss will win. Each game means each customer. Okay. Each policy. If you sign one contract, the boss will win this. Sign another. If you sign 100, the boss will win 270 times 100. Imagine. That's true. Okay. Insurance company need to earn money. Okay. Otherwise, no one would do insurance company. Let me. Any question? So look at this a little more complicated for the outcomes. I'll do another 2 questions. So a company estimated that 0.5% of their product will fail after the original warranty period with the replacement cost of $100. So they are talking about the insurance, right? So you buy insurance, okay? Outside of the basic warranty, okay? So after the warranty, sometimes we buy, right? Sometimes, okay. And then now to look at what the company's expected value. We are talking about the company. If you are the boss of the company, just think about it. Is this a good policy you set up? Okay, you need to set up the insurance fee so that you have expected value greater than 0, right? Definitely, okay. If you are the boss, you need to set up how much insurance, you need, so that in average speaking, I need to get money. Otherwise, I will not, to do this company. This is easy. These questions are much easier. Abby, so Abby, can you try work on this question for us? Yeah, good. I just wanted you to figure out these 1, 2, 3, 4. So how do you say? I will not say when. How do you say? I use fair or not fair. Is that okay? To tell the two cases. If the product is fair, or if the product is not fair. Okay. See, that's all two cases. If this is a no, not fair. The product is not fair. Oops. If the product is not fair, if the product is fair, you know what that is mean. So now this is, think about it, the company's expected value. Can you one by one think about what this? If the product is not fair, how about the company's outcome? It should be which number or the combination of some numbers, right? Not fair. See, they're talking about a product, okay, and then we sign a contract with the customer. Okay, the customer spend $43 to buy the insurance, right? You are the boss. And then after the period of whatever 2 years, and then the product is not fair. See, the case is there. You are the boss of the company. You should earn money, right? You earn how much? For this one case, this is talking about the one case. Or anyone? Yeah, happy? No? Or anyone help to get the first box? Or if someone get it disconnected? Okay, no problem. Yeah, Paris. You want to be? Yeah, okay, no problem. Yeah. Okay, good. Yeah, let me just ask, these number put it here or here, the top or the bottom? On the bottom. Okay, good. That's correct. Because of what? Fair. This probability to fail. Okay, good. Fail, which is a point. Let me use the decimal. This equals 0.005. No problem, right? Okay. So I put the probability here. So therefore, and the Maris, can you again get the probability there?
That 0.005 from 1, and then the answer is not.
Yeah, 995. Very good, thank you. So we figure out the probability, but we yet not figure out what's the outcome. See, so look at the questions. Only have this number and this number, right? This is the insurance pay. If the product is no fair, not fair, so the insurance company don't need to pay any money, so that the insurance company get the money. It's positive, right? So how about the fair? If it's fair, Is this true? No. No matter the product fair or not fair, the boss or the company need to get the insurance, right? So it's 40 minus this. 43 is positive because the company need to get the insurance, okay? Get in and they get out. Earn, spend, and then do calculation. You will negative 457 dollars. Is that okay? This number is the fair, and then if you get it, and now it's easy. These numbers come together, the two numbers come together, right? So Abby, is this okay? Okay, good. So we get it. So you do calculation, not just a leave. Calculation is 43 times 0.995, and then plus negative 457 times 0.005. I don't know. Okay, I'll leave you to do calculation. Should be a positive number. So almost at the time. Let's get it. Is that okay? That's one question. The question is easy, but I have a new type, and we have more than 2 outcomes. It is okay. So let me see. Please, everyone, read the question. This time a little different. You will have more than 2 outcomes, no matter how many outcomes the way at the same. How many outcomes? We just talking about in like a game. Okay, it's a wrap ticket. We have one first prize, and then second prize, and then third prize, and then no prize, right? 4 cases. Okay. First prize, the first place. Okay, first prize, you win, or win the second prize, still win, or win the third prize, still win. But lose is no win, and no prize, or say no prize. Is this 1, 2, 3, 4 cases? Okay, this time. Can you get what the number? What the outcome for the first? I think now easy, right? This number. Everyone see? We just extended the outcome to 4 cases. Okay. Get this money. Get this money. Get this money. So here did not say 0, right? Okay. Of course, I did not get a prize. Of course, it means 0. I don't need the money to play the game. It says if you are given 1 ticket, no cost for the game. And then the last is what the probability here, probability here, probability here, probability here. Andy, what do you think? What the probability to get the first prize? Well, everyone, think about it. The last. Okay, so we finish this topic. Yeah. Good. Why? Yes. 1. See, 1 out of 10,000. 10,000. Only 1, the first prize and the photo. Okay, and then what the second? 4 out of 10,000. Still 10,000. Okay. Still 10,000. Because 4 is the success. The total is 10,000. And then the last is 8. This is the chance. If you randomly pick 1, okay, this is the chance to get the prize. 10,000. And then the last one is 1 minus all this. So 1 minus 1 plus 4 plus 8, which is 13, right? So 1 minus 13 out of 10,000. Is that okay? And then follow the same. I will not do the calculation. I'll leave the calculation for you. 1 product, 2 product, 3 product, the last product, lastly is 0, okay? And then the same, because bracket the value will be equals this after this. And the last 300, and then times 0 times this. You do calculation for yourself. And that's all for the day. Everyone, thank you.